All right, so let's take a look at this question 13 one more time. All right? Limiting reactant questions, you don't want to do them with fence posts. It's way too many steps. It's hard to remember those steps. The rice chart, if you learn how to do it now, is going to set you up for equilibrium later on. So this is how I want work done. Okay? It's going to take you a fifth the time to come up with the answers for all your questions. And the issue with these limiting reactant questions is it isn't just a one-part question. You guys looked at page 113, right? Each question has numerous parts, right? They'll ask, how much of this product do you make? Who's excess? How much excess is left over? And so if you have to do it with fence posts, it's going to take half a lifetime. With a rice chart, you can answer all of those questions in one sitting. You just have to know how to fill out the rice chart. All right. For now, rice stands for reaction, initial, coefficients, end. Later on, when we get to equilibrium, we're going to change what that acronym stands for. When we get to equilibrium, it'll stand for reaction, initial, change, and equilibrium. But it's still the same relative idea. All right? So the first thing that you do, step one, is you fill in the reaction in the R line. What was the reaction that we were using here?
1N2 plus 3H2 yields 2NH3.
And the original question that they asked was if I had 5 grams of nitrogen and 12 grams of ammonia, 12 grams of hydrogen. Like, how many grams of ammonia do you make, right? Who's the excess reactant? How much is left over? All right? So step one was fill in the R line with the balanced equation. That's easy enough to do, right? Okay, step two. We're going to fill in the initial quantities in this first row. The issue with the rice chart is that it only takes the almighty unit in chemistry, which is the mole. So they didn't give you these numbers in moles. They gave them to me in grams. So I'm going to have to do a quick conversion. So what was I initially given for nitrogen? I was given 5 grams, right? And what was I given for hydrogen? 12 grams. That's not the correct unit that I want. So I'm just going to go ahead and do that quick division by the molar mass within that box just to change it to moles. What's the molar mass for nitrogen? 28.02. Some people told me it was 14 yesterday. What's wrong with that?
It's diatomic.
Yeah, it's diatomic. You have to account for the fact that there's 2 atoms of nitrogen in the formula. All right, so 5 divided by 28.02, what do we get? 0.18 moles. And then over here, what do we have? 5.94 moles. And how much ammonia did I put in here? 0. All right, so step 2, you're going to fill in the I line with your givens in mole. Enter a 0 for the product. Why are we entering a 0 for the product? We haven't made it yet. Perfect. All right, step 3. I'm going to go ahead and fill in the coefficients line. This is going to read minus 1x, minus 3x, plus 2x. Right? So we fill in the C line with coefficients. Why am I subtracting on the left? Because you're taking them away. Why am I adding on the right? Because you're making them. All right? And where do these numbers come from? The balanced chemical equation. Right? So subtract from left, add on right. Okay, step 4. This is the critical one. This is the one that you really have to focus on. Okay, and this is where I kind of messed up a little bit yesterday when I was doing this with you, because I was kind of in a rush. All right, I'm going to do this in a different color, because this is a side calculation. All right, so you're going to take this first number in the first box, whatever it is, and you're going to multiply it by the coefficient in that second reactant over the coefficient for the first reactant, right? So I wrote 0.18 times 3 over 1. So, given in first box times coefficient for the second reactant over coefficient for first reactant. All right, so what is that? 0.18 times 3. What is that? 0.54. You're going to take a mental note of that value and you're going to compare it to the number in the box in the second column. Is 0.54 greater than 5.94, equal to, or less than?
Less.
So I'm going to draw an inequality right there between the boxes. Okay? So compare the answer to value in second box I line and write greater than, less than, or equal in between. All right? Okay, so that inequality is an arrowhead. It's pointing you towards the limiting reactant. Okay? So which of these compounds is the limiting reactant in this equation? It's the nitrogen. So I'm going to go ahead and write LR on top. If this is the limiting reactant, then what does that tell me about the hydrogen? It's the excess reactant. So I'm going to abbreviate ER above and label it. Okay? All right. The beauty of identifying that limiting reactant is that now I know how to complete this column for that particular substance. You have to remember the definition of limiting reactant. It is what limits how much product you make, and what's the second definition?
And it's used up.
It's used up. So if it's used up, how much do you have at the end? 0. All right? So you enter a 0 in the E line for the limiting reactant. All right, so we have just climaxed. This is like the hardest part is getting to step 4. From here on out, everything's downhill. It's going to go fast, okay? So what we're going to do now is some algebra. We're going to do it over here on the far right. You see how I have a completed column? A completed column allows me to write an algebraic expression. And the algebraic expression is based on the idea that the I line plus the C line equals the E line. All right? So I'm going to say 0.18, and this is where I messed up yesterday, 0.18 minus X equals 0. What did I do yesterday? Yeah, I shouldn't have. That 0.54 is just to figure out who the limiting reactant is. When you actually come up with that algebraic expression, it should just be based on that actual number without multiplying by the ratio. Okay? That's where I messed up. Is that easy algebra to solve for? Yes. And so how do you get X?
0.18.
X equals 0.18. And so now that you know what 0.18, we can go back and substitute. So this E line here, again, would be from taking the I line for that column, 5.94, and adding it to the C line, minus 3X, right? But now I know what X is, right? So couldn't I just substitute that? So I'm going to go ahead and substitute 0.18. So it's 5.94 minus 3 times 0.18. Is it 5.4? 5.4. And then what about this? This would be 0 plus 2 times X. But now I know what X is. So that'd be 0.36. All right, now, what are those units in?
Mole.
They're in mole. Did I want mole? No, I wanted grams. And so if I had to come into the chart by dividing with the molar masses, how do I come out of the chart if I went back in grams? I'm going to multiply by the molar mass. So, for instance, here I would take 5.4 and multiply by 2.02, which that's the molar mass of hydrogen. And here you would take 0.36 and multiply it by 17.04, which would be the molar mass for ammonia. All right, so for the first one, 5.4 times 2.02, I get 10.9 grams. And then over here, 0.36 times 17.04, we get 6.1 grams of NH3, and this is H2. All right, so again, step 5, all right, I plus C equals E. You're going to do that with values for the completed column You're going to solve for x, and then you're going to substitute x into the rest of the chart and finish filling out the chart. All right, so was that easier to fill out the chart than doing all those fence posts? You betcha. Now, what does the chart tell me? At the end of the day, once the reaction's done, how much nitrogen is in that beaker? None. How much hydrogen's in the beaker? 10.9. So I had 10.9 grams of the stuff left over. Leave it. I'll take care of it later. Okay. He didn't do anything. It was me. 10.9 grams left over. That's H2, not H2O. All right. How much ammonia did I make? 6.1 grams. All right. So we answered all of the questions in one fell swoop. Okay. Now, what if you had misidentified the limiting reactant? All right, but would you be able to tell?
Yes.
You sure can. How would you be able to tell? You would get a negative in one of these boxes. You can't get negative quantities. All right. So right. So if you're doing the table and you end up seeing a negative value down here for any one of these things, start over and choose the other substance as your limiting reactant. Okay. All right. What if there's 3 substances and you add another column? You still have to figure out who the limiting reactant is, and so then you'd have to do a little bit more work there. Give me a second. One more thing. What if you put an equal sign there between columns? Then they both get used up, and so then you would put a 0 there and a 0 there. You could write an algebraic expression from either column. The value for x would be the same, right? You'd solve for x. Both are limiting because both would go away. So you would just put in a 0 there, 0 there. Both are limiting. If you use either column to figure out what x is, and then solve for x, and then plug it into the last column to figure out how much product you made. Yeah, what's your question?
So if you have more than one product, you
Add another column. Okay? All right, so let's take a look at this last page. Let's do some more practice problems. So here's a new reaction. How many moles of MgO are produced from 3 moles of Mg and 5 moles O2? This is easier because this is in moles. I'm asking for answers in moles. So this is just intended to get you to set up just the basic rice chart. All right, so what do I need here? You got to balance it, right? What's wrong? I need a 2 here and a 2 there. I'm asking a bunch of questions. I'm asking how much magnesium oxide do I make? I'm asking who is excess, how much is left over. We can do it all in one sitting just by filling out that table. All right? So let's start. R. What goes in R? 2 Mg plus O2 yields 2 MgO. What goes in I? Your givens. In what unit? Are they a mole already? Hey. Oh, no. Okay, guys, I'm going to finish recording this. I'll put it on eCampus. Please watch it.